How are you guys? Welcome back to my YouTube channel. We have the problem here. Read as follow. This is question one. Um, 8A chemical plant liquid propane is pumped through a pipeline that is initially 120 millimeter in diameter, turns vertically and then increase in diameter to 300 millimeter, leaving at vertically of 4.5 meters per second as illustrated in the figure below. We have the vertical pipe. This is a flow, the water flow vertically upwards. This is a vertical flow of water. Well, we have pipe. They've shown the pipe. They've given us pressures at the diameter. We can say because the water initially, we can call this will be pressure 1, this will be P1, then this one will be pressure 2, Why? Because initially the water start from 121. You see the diameter means initially the water goes through this direction, started from the bottom. We take the bottom as a reference. So this will be diameter 1, pressure 1, all of these things, We have given h, we don't know the length of h, is just h there, right? So the question 1.1.1, it consists, says the figure here, if the flow in vertical through this reduced section has been added to increase the pressure from, you see this is initial, this from, that means from 8 initially. From, when you see from, you can replace with initial. It's the initial pressure, that one, from 80 kilopascal to 2 means final. 2 is the second one, which is 370 kilopascal. Determine the following. 1.1.1, the flow rate through the section. The flow rate through the section, that means we're talking about this whole pipe, right? Through the sections, we want the flow rate. The flow rate is the same throughout. What in liters per second. 1.1.2, the height h of the reduce, the one that h height, right? So we want the flow rate, right? We want the flow rate. What do we know? We're given the diameter, also given a velocity. Yet we know that the flow rate is the same throughout. The flow rate here at this point, at that point is the same throughout. That means we know that Q is equal to area multiplied by velocity, right? So we'll use this formula. We can find the area here in this portion in the top part, because you have 300 millimeter. We also have what? The velocity. Then we can calculate it. Then let us answer this question. The flow rate there, this is 1.1.1, right? 1.1.1. Want to calculate the flow rate through the section. We know that the flow rate is equal to Q, right, is equal to area multiplied by V, which is velocity. Area is pi over 4. It's pi over 4 multiplied by what? By D, right? Multiplied by D. We know that that is the area, right? Multiplied by D squared. We have D squared, right? Multiplied by D squared. Then we multiply this by the velocity, right? So we know that the diameter here is 300 millimeter, divided by 1000 will be 0.3. Then we have the velocity. Then we can quickly, we know that this will be equal to pi over 4 into the diameter is 0. It is 0.3, right? You square that means when you square this the same as you multiply again by 0.3. Remember, square represent this is the same as square. That means you multiply by something 2 times. So then you multiply this by the velocity, which is the velocity there is 0, what is the velocity there? Velocity will be 4.5 that we've given, 4.5, right? Then you punch this on your calculator. We're supposed to get that the velocity or the q, the flow rate q will be equal to, when you punch that on your calculator, supposed to get that, remember, must be in liters per second, right? So I will get the answer in cubic first, which is 0.3195, right? Cubic, this will be in cubic per second, right? But now the question, they say they want this in liters per second, right? Then I'll multiply this answer by 1000, convert this, multiply this by 1000, then q, therefore q will be equal to 3,319,5 liters per second. This is our answer in liters per seconds. This is q, right? Then the following question 1.1.2 says determine the height. They want this height h. They want us to determine h, determine the height of the reducer section. To apply this, obviously we're supposed to apply the Bernoulli's equation, because we know the information. We have the diameter there in the inlet, which is 120, and the pressure in the inlet, right? But do we have the velocity in the inlet? We don't have the velocity here. V1, we don't have V1 here in the inlet. We're supposed to calculate the velocity, but we know that Q is the same throughout. Let us calculate first before we use Bernoulli's. I want us first to calculate velocity there. 1.1.2. Want us to calculate first the velocity. We'll call this V1, right? Because it's the one of the inlet. V1 must be equal to Q over area. Then Q, we have calculated Q. We got that Q, remember, in the above, which is, we got that Q was 0, Q is 0. We know that Q is 0.3195, right? Then divide this into the area, which is the area is the one is here. If we punch this, will give us area. If we punch that, here it's the area. If you punch this on the calculator, it will give you area only. All right, then supposed to get that the area will be, when you've punched that, 0,071 is 0,071. This is the area, right? So since you found the area, punch this on your calculator so that we get V1. 0,315 divided by 0,71, then we'll get V1, which is V1 V1 will be equal to, punch that will be 28,909. right? This is in cubic, well, this is in meters per seconds. This is a velocity, this is our velocity, right? We have the velocity, which is V1. Now we can use Bernoulli's equation. Bernoulli's equation says that it will be Z1 plus, right, pressure 1 over density, which is rho, multiplied by gravity, p plus, again, plus V1 squared all over 2g. This must be equal to Z2 plus P, you can say P2, some they use R, PR1, PR2, but it's the one and the same thing, divided by rho times gravity plus V2 squared, you square that, over 2g. This is the Bernoulli's equation. This is how we apply the Bernoulli's equation. This will be Bernoulli's, right? So we'll apply this equation. Right, so let us substitute. What do we have? Z1, come here, remember Z1 is a reference, which is will be what, 0. Z1 here, we'll take it as a reference, will be 0. Z1 will be 0 plus pressure 1 we are given. There was pressure 1 is 80 kilopascal. 80 kilopascal, 80, it's 80 kilopascal. This is 0, 80 kilopascal times 10 to the power of 3 divided by, it's water, right? The one that there is water that is flowing, that means the density of what is 1000. This 1000 times 9,81, which is gravity, right? This must be equal, this must be plus v1 squared. Remember, we apply this formula, plus v1 squared. v1 we've calculated it. Here it's v1 28,909. v1 is 28,909. Square this, divide this by 2 times 9,81, right? Right, then all of these must be is what we have on the left hand side. This must be equal, z2 is h, this will be h, right? Let me check that h is written, which here is h, right? Then we have z1 is h, also pressure 2 is 370 there. It's a matter of substituting plus pressure 370 kilopascal, 370 times 10 to the power of 3 divided by 1000 times 9,81, right? Plus v2, which is 4.5, you square that, 4.5 square, divide this by 2 times 9,81, right? Then you punch this, we'll have, if I'm starting by this side, if I punch this on the calculator, I will get that my left hand side, I punch it, all of that, I got that is 50, I got 50, 751, then this will be equal, then I punch all of these there in the calculator, I will get that h plus 37,717. No, this will be equal to 38,748, right? Then I will have this, make h the subject, h would be equal to 50,715 minus 38,748, right? Punch this on the calculator, get that, you'll get that h is equal to 12,0003 meat is measured in meat. This is our answer here. Right, thank you guys for your time. Thank you once more. Subscribe to my YouTube channel so that you'll be notified whenever I post some new videos. Right, I hope you understood this. Right. Yeah, we have found these are the steps that we've did. Hopefully here you understood here.